Welcome to Sundar's lecture. This is lecture number 34, and in this lecture we are going to see phase and phase difference, right? So what are all the topics we have seen in the last class? See, we have taken an example problem, and before that we have derived these expressions, right? Average value and what is the peak factor and form factor, all those kind of things we have seen in the last class. And also we have taken an example problem and we have found all the values, all maximum value, frequency and so many AC quantity values has been found with the example problem, right? So in this class, before entering into the what is AC through resistor, inductor and capacitor, we need to know what is the phase and phase difference. That is very important here, right? So what is that? See how this waveform is coming. We have seen this. We have seen this by using the using the expression I is equal to Im sin omega t. Instead of omega t, we have substituted what is the theta values, 0, 45 degree and 90 degree and so many things, right? So we have seen this diagram, but how we can represent the phasors, right? So this is actually a circle. This waveform will be a circle if you want to represent in the phasors, right? So this is the 45 degree split up. See, this circle has been splitted into 45 degrees. See, this is the reference and this is the A point, this is B, this is C, this is D, E, F, G, H, and I and A will be same. Why? Because 360 degree and 0 degree will be same. See, this, I have written here A is equal to 0 degree, that is 0 degree, and what is B? That is nothing but 45 degree. Then C is equal to 90, D is equal to 135, and E is equal to 180. Opposite, right? 0 and 180 will be in the opposite directions. And also F is equal to 225, Y is equal to 270, H is equal to 315, and I, if you want to write I and A will be same. That is 0 degree and 360 degree, right? So if you are drawing a graph like this, and this point will be what? 45 degree, and this point we already know, always sine wave will be maximum if the degree is 90, right? That is theta is 90. So this is the maximum, and this is nothing but the D point, which is nothing but 135 degree, and we have seen this, and this is in the negative maximum will come under 270 degree. Just we have drawn this graph with the reference circle now. And now, for example, if we are having two values of current, one is I1, that is Im sin omega t, and I2, that is Im sin omega t plus 45 degree. I have not told you what is this plus 45 degree, and I will tell you why this plus 45 degree is coming, minus 45 degree is coming, all those kind of things we will see while going for resistor, inductor and capacitor, AC to resistor, inductor and capacitor. Before that, you try to understand what is the plus pi. See this one, this is the expression actually. I1 is equal to Im sin omega t. If you are having an expression, that is I is equal to Im sin of omega t plus pi. And what is this pi? This pi we always write, see, pi, which is nothing but phase difference value. Phase difference. We always call this pi as a phase difference. See, if you are seeing a plus pi, you just compare with I with I1 with I2. I1 is Im sin omega t. Always Im sin omega t will be the reference value. See, we have known that. We know this, right? So your graph will start from this point and it will come like this and it will be going like this, right? So this is nothing but Im sin omega t. If your if the another expression, it is like this, right? So this is plus pi. Instead of pi, I have taken 45 degree here. So I2 will be is equal to Im sin omega t plus 45 degree, which means this phasor leads the reference by 45 degree. Why this is plus? Here it is plus. If it is plus, then the phasor will lead the reference phasor by 45 degree, right? So how it will be coming, right? See, this is the reference phasor, that is I1 is equal to Im sin omega t, and you see this is plus 45 degree, then this curve starts from 45 degree. See, this is the 45 degree, right? You can see here. So this is A, which is nothing but 0 degree, and what is B? B, which is nothing but what, 45 degree. And you see I have extended this line, and this line, which is nothing but the reference line, 0 point, and your graph will start from this point. Or this is what this is A, and this is nothing but what, 45 degree in the negative direction, but this curve will start from here. And always you see this is the maximum point. Reaching maximum point for I1 will be this point, and for I2, which is this point, which means what is the difference between these 2 points? That is nothing but 45 degree, which means I2 phasor will get maximum value before the reference phasor by 45 degree. And also you see at this point the reference phasor is getting to 0, and you see before 45 degree itself the I2 phasor will get to 0. And also in the negative direction, this is the negative maximum point, this is reference phasor, and the I2 value will reach negative maximum before the reference phasor by 45 degree. And also to 0 point also you see this reference phasor is reaching at this point, and the I2 phasor reaching 0 before this reference phasor by 45 degree. And what is the difference between these two? What is the difference between these two? Which is nothing but, this is nothing but 45 degree. 45 degree, and that is what the here you see this value, which is nothing but, this is actually pi, this is pi, right? So this will be pi, that is nothing but this angle is 45 degree. So you can represent the phasors like this. So if you are taking a phasor diagram, how we can draw the phasor diagram? See, phasor diagrams can be drawn like this. So which is the reference phasor here? I1 is the reference phasor, right? So I1 will be this one, and I2 will be what? 45 degree leading. 45 degree leading means you have to draw above the I1, and you make this angle as 45 degree. So I1 and I2, we can represent it in the phasor diagram. This is nothing but we are calling it as phasor diagrams, right? So I1 leads I2 by 45 degree. That you have to understand from the expression itself, but also you can draw this expressions like this also, right? I1, which is reference phasor, and I2, which is nothing but the value, and that leads by 45 degree. That is one thing. Next one, you see this one, this is also we can say this is lead phase. Why we are calling this as lead phase? Because I2 leads the I1 by 45 degree. That is why we are calling it as lead phase, right? So next one, we go for lag phase, which means what? It is very simple to understand. If this is the I1, that means the reference phasor I is equal to Im sin omega t, that is nothing but this phase, and I2, which is nothing but Im sin of omega t minus 45 degree. If it is minus 45 degree, you see it has come here, it has came here. This is actually pi, not theta, because you don't confuse yourself. This is pi. So pi. So this is minus 45 degree. Then what happens now? At this point, I have extended this point here. At the 0 instant, your graph will start from this point. That means I2 will start from this point, and it will go like this. See this one. Where is the maximum point? It is the maximum point. See, your reference phasor has reached the maximum point at this point, and your I2, that is Im sin omega t minus 45 degree, reaching the maximum point after the reference phasor by 45 degree. What is the difference between these two? What is the difference? What is the difference? This is nothing but what? 45 degree. 45 degree. And you see your reference phasor has reached the maximum value before the I2 by 45 degree, right? Your I2 phase are reaching the maximum value after the reference value. That is the point you have to take. And also you see this 0.0, this is the reference 0, but this is the I2 0. I2 0 has been reached after 45 degree. That is the point you have to understand, which means the I2 phasor is lagging the reference phasor by 45 degree. By 45 degree. That is the point you have to understand here. So if you want to draw the phasor diagram, see, this is the reference phasor, that is I1, that is nothing but Im sin omega t. Always wherever you see Im sin omega t or Vm sin omega t, all those kind of things will be the reference value. So this is the reference. And what is I2? I2 will be omega Im sin omega t minus 45 degree. Then what happens? If it is plus 45 degree, then this phase will leads the I1, but this is lagging, so we are drawing like this. So this is nothing but 45 degree, and if you see a graph like this, you can directly say that the reference phasor, sorry, the I2 phasor lags the reference phasor by 45 degree. That you have to represent like this. And what is the next one? Here, see this one. What is in phase now? What is in phase? For example, I will write here. Maybe this is in phase. In phase. There are three phases. One is in phase, another one is leading phase, another one is lagging phase. We have seen what is leading phase, what is lagging phase, but we have not seen in phase, right? So if you are going for in phase, I just try to explain with this graph itself, and then what I need to do, if this is I1, if this is I1, then I try to write this I2, which is equal to Im sin omega t, and just directly writing. See, I1 and I2 are same values. Then what happens? Then what happens? I2 will be also coming like this. See, there is no phase difference. There is no phase difference. And if you want to draw the phasor diagram, what happens? So this, if this is I1, then I2 will be same. So what is the phase difference between these two? That means here pi will be equal to 0 degree. Pi will be is equal to 0 degree. There is no difference. There is no difference between one phase and another phase. If it is like this, then we always call those kind of things as a in phase values. Both phasors will be same. That is one thing, right? So here we have taken an example for in phase, lag phase, and lead phase with the same maximum value. See, I am in I1, I am, and in I2, I am are same. And also in the lag phase also, we have taken I1, I2, only we have differed these two expressions by 45 degree phasor difference, not by the maximum values, right? This is Im, this is Im, right? And also, if you are going for lag phase also, we have taken the Im values as same, but it can be a different value. It can be a different value. For example, I am taking it as a voltage. See, this circle represents the voltage value, that is Vm, and I am taking it as reference value. V is equal to Vm sin omega t, and the second phasor I have taken I is equal to Im sin of omega t plus pi. Which means what is this? Plus pi means what? My I will lead the voltage by 45 degree. Right? You see, maximum value has been reached in a different way. This Im is greater here. So that is what, sorry, Vm will be higher than Im. See, we have shown a difference here, and also a phase difference. How these two phasors will be different? That means 45 degrees. See, if your I which is equal to sine of omega t plus pi, if it is pi is equal to 45 degree, then what happens to your I will be reaching to maximum point before the value of maximum Vm by 45 degree. The phase difference will be 45 degree. And what is the phase difference? Phase difference will be 45 degree. So this is one thing. This is one thing. Right? So this is the point you have to understand, and I have written here. This is the phasor with a different magnitude. That means it may be I1, I2. See, it may be I1 is equal to Im1 sin omega t and I2 is equal to Im2 sin omega t plus 45 degree. That it can be written like this also, like that also. You don't confuse yourself. We need to have two different maximum values. I have taken it for V and I have given it a different names here. So you can easily understand this is the phasor with a different magnitude. All these in phase, lagging phase and leading phase, I've shown an example with the same magnitude, but I want to tell you that it can be a different magnitude. But once if you are going for expressions in the AC circuit, then obviously it will be different maximum values, different magnitude values, right? So here it is the phasor with a different magnitude, which means Vm will be greater than Im, and also I phasor leads the V phasor by 45 degree. I have taken everything in the same example, right? So you see this 0 point, this is the maximum point of V, but this maximum point of I has came before the V by 45 degree, and also for 0 and negative maximum and 0 again, everything will come for the I phasor. It will leads the V phasor by 45 degree and has a different magnitude. That's a different magnitude. This is how you need to draw the diagram. And if you want to draw the phasor diagram for this one, we will take a different page. See for this one, for V is equal to Vm sin omega t. So I will write the expression V is equal to Vm sin omega t. That is the reference phasor, right? Always we will write this as reference phasor. And I, what is the thing we have taken? That is nothing but Im sin of omega t plus pi, right? And here we know that Vm, here we know that Vm is greater than Im. That also you have to understand, right? So if you want to draw the phasor diagram, if it is like this, so this is the reference phasor. This is the reference phasor. Always you have to take reference phasor at this point, at the x-axis point. Try to understand. This is Vm, and this Vm will have more magnitude which is higher than Im. So I have drawn like this. And what is Im? Im will be like this. See, this is my Im. And what is the phase difference? This plus pi. I have taken pi as the 45 degree. So this will be like this. Pi is equal to 45 degree. So it will be like this. See, the maximum value phasor Im is greater than Vm. Sorry, Vm is greater than Im. And you see here, everywhere you go, I have taken the same magnitudes because both magnitudes are same here. But here it will be lesser than Vm. Im will be lesser than Vm, but it is leading by 45 degree. That's all. This is how you need to draw the phasor diagrams. So try to draw the phasor diagrams, and that will help you because we are going to draw phasor diagrams everywhere. We are wherever we are going with the expressions. Understanding things in AC circuits by using phasor diagrams will give you better insight to the concepts. That is why I'm concentrating on drawing the phasor diagrams clearly, right? So in the next class, we try to derive the expression for AC through resistor, inductor and capacitor, right? Now you know what is leading phasor, what is lagging phasor, what is in phase, and all those kind of things, and different magnitude, how you need to draw the phasor diagrams for different magnitude values, that is different maximum values, and with the same maximum values with the different phasor differences, that means 45 degree plus 45 minus 45, all those kind of things we have seen in the class. So we try to solve, or we try to derive the expressions for resistor, inductor, capacitor by AC source in the next class. Thank you. Go through this.